Welcome. Today we're diving into something that literally impacts your daily comfort, your monthly budget, and your home's energy footprint. We're talking about the absolute dream for any household, getting a truly endless supply of hot water without wasting energy or breaking the bank. In this explainer, we're going to unpack the totally fascinating tech behind tankless water heaters. Specifically, we're looking at the ultimate showdown, condensing versus non-condensing models. By the end of this, you're going to know exactly which system is the perfect match for your home.
Okay, let's dive into this. Here's our roadmap for the explainer. First, endless hot water basics. Then we'll look at the non-condensing workhorse, followed by the condensing innovator. We'll do a head-to-head comparison, and finally, we'll help you make your final choice. So, moving right into Section 1, Endless Hot Water Basics. Let's look at how tankless technology actually works.
Before we compare the two types, we kind of need to demystify exactly what happens behind the scenes when you turn on the tap. The absolute key phrase here is on demand. See, traditional water heaters rely on a massive 40 to 80-gallon storage tank. It's basically a giant, space-hogging roommate that constantly heats and reheats standing water 24/7 just so it's ready when you need it. Well, a tankless water heater completely ditches that tank. It saves massive physical space, and more importantly, it eliminates what's called standby heat loss, because you're literally only paying to heat the water you are actively using.
Now, you might be wondering, how does it actually do this so fast? It's a pretty brilliant three-step process. Step 1, you turn on your shower, and a highly sensitive flow sensor inside the unit instantly detects that water movement. Step 2, this sensor signals the computer control board to ignite a massive gas burner or electric element. And I mean massive. We're talking about burners capable of pumping out 150,000 to 200,000 BTUs of heat. Step 3, that cold water is forced through a heat exchanger, which is basically this labyrinth of tightly coiled tubes surrounded by all that intense heat. The water warms up in literally seconds as it travels through, delivering a perfectly heated stream straight to your shower head.
Okay, so the amount of heavy lifting the unit has to do really depends on the temperature rise. In moderate climates, your incoming city or well water might be sitting right around 60 degrees. To get that up to a nice, steamy 120 degrees for your shower, the unit needs to achieve a temperature rise of 50 to 60 degrees Fahrenheit. Simply put, the harder the unit has to work to close that temperature gap, the lower your maximum water flow rate will be. All right, on to Section 2, the non-condensing workhorse. Let's meet the reliable veteran.
With the basics out of the way, let's meet our first contender in this showdown. The non-condensing unit relies on a brilliantly simple single exchanger design. If you compare it directly to an old-school storage tank, it's already leaps and bounds ahead in efficiency, simply because it completely eliminates that standby heat loss we talked about. It really just does one job, does it incredibly well, and it's been the industry standard for decades.
But here is the catch with that single heat exchanger design. When those massive gas burners fire up, they create a lot of exhaust. In a non-condensing unit, those exhaust gases leave the heat exchanger at a scorching 300 to 500 degrees Fahrenheit. All of that heat is just blown right outside your house. That is wasted energy that you paid for. Plus, because the exhaust is so incredibly hot, you absolutely cannot use standard plastic pipes for venting. No way! These units legally require specialized and frankly very expensive stainless steel or high-temperature venting materials, otherwise the pipes would literally melt inside your walls. Now, what's really interesting here is that despite that energy loss, this older tech is still a fantastic budget-friendly choice. Because it has only one heat exchanger, the unit itself is usually $500 to $1,500 cheaper upfront. It has a simpler design with fewer parts that can break down, a significantly smaller physical footprint, and because the exhaust is so hot, all the moisture just burns off. That means there's no complex condensate drainage to worry about during installation. It's just a proven, rugged machine.
Moving on to Section 3, the Condensing Innovator, the high-efficiency upgrade.
So what if we could somehow capture that wasted 500-degree exhaust heat? Well, here is the absolute genius of the condensing unit. It uses dual heat exchangers instead of just one. You can think of this secondary heat exchanger almost like a thermal sponge. Before those scorching exhaust gases are allowed to escape out of your house, they get routed through this second, sponge-like exchanger. The incoming cold water passes through this secondary exchanger first, preheating itself using the exhaust gases. It brilliantly captures all that thermal energy that the non-condensing unit just throws right out the window.
And because that secondary heat exchanger absorbs so much of the exhaust heat, the gases that finally do exit your house are drastically cooled down. We're talking about exhaust temperatures of just 100 to 120 degrees Fahrenheit, which is a huge drop compared to the 500 degrees we saw with contender number 1. This is a massive game changer for installation because it safely allows your installer to use cheap, flexible PVC or CPVC piping for the venting. Honestly, the savings on venting materials alone can sometimes totally offset the higher cost of the unit itself.
Now, we do need to be completely transparent and address a slight installation complication with this high-efficiency process. Because you're pulling so much heat out of the exhaust gases, the water vapor inside those gases rapidly cools and condenses into a liquid state. And this liquid condensation is actually quite acidic. You can't just let it drip anywhere. A condensing unit requires a dedicated drain line, and depending on your local building codes, you might also need to install a small neutralizer cartridge that just balances the pH of the acidic water before it safely enters your home's plumbing system.
So the crucial point here is that while you definitely pay more upfront for this complex dual exchanger unit, the long-term benefits are really staggering. These units operate at a near-perfect 90 to 98% energy efficiency. They use 10 to 15% less natural gas, which easily saves you $50 to $150 annually on your utility bills. Plus, you're lowering your home's carbon footprint, and because they're so green, they frequently qualify for some pretty hefty utility rebates and federal tax incentives.
That brings us to Section 4, Head-to-Head Comparison, the final weigh-in. We've met the contenders, so let's finally put them side by side. I highly recommend taking a quick screenshot of this matrix right now for your purchasing records, because it truly says it all. You can really see the push and pull here. The condensing unit wins heavily on efficiency and lifetime savings, potentially keeping up to $3,000 in your pocket over its 20-year lifespan. Plus, it utilizes that cheaper PVC venting. On the flip side, the non-condensing unit saves you up to $1,500 right out of the gate, though remember, you do have to shell out for that expensive stainless steel venting.
And when you look at the numbers, it undeniably proves who wins the pure efficiency battle. With a maximum score of 85%, the non-condensing unit is definitely good. But at a staggering 98%, the condensing unit is literally squeezing almost every single penny of heat out of the gas you're paying for.
Finally, Section 5, Making Your Final Choice. The verdict.
With all the data on the table, let's figure out the personal winner based on your specific home, budget, and lifestyle. Here is exactly when the reliable veteran model is the smartest financial play. You should definitely choose the non-condensing unit if you're working with a tight upfront budget and you just need to keep initial costs down. It's also the clear winner if your installation space, like a tiny utility closet, is exceptionally narrow and literally can't fit the slightly bulkier dual exchanger unit. And finally, if you're outfitting a vacation home, or you live alone and your overall hot water usage is just very low, the sheer math means you'll probably never use enough hot water to justify the higher cost of a high-efficiency unit.
On the other hand, you should absolutely invest the extra money up front for the condensing unit if you plan to stay in your home long-term, meaning you'll actually be there to reap those decades of energy savings. In that case, it's a total no-brainer. It's also ideal if you have a bustling household with high daily hot water usage. It's the clear choice for eco-conscious homeowners wanting to lower their carbon footprint. And practically speaking, if the architecture of your home makes running rigid stainless steel exhaust pipes impossible, the flexible PVC venting of a condensing unit might literally be your only viable option anyway.
Ultimately, when we look at the source material, analyzing typical modern installations, this is the final expert consensus. For most homeowners, condensing tankless water heaters deliver the best long-term value. The combination of superior efficiency, lower operational costs, and the flexibility of installation almost always overshadows that initial price bump. Which brings us to our final thought. The tech is amazing, but the best unit is the one that fits your life. So I want you to ask yourself, what are your home's unique plumbing constraints? And what are your long-term energy goals? Take a look at your utility closet. Think about your daily hot water habits. And with all this knowledge in hand, you're now fully equipped to make a confident, informed decision when you call a professional installer. Thank you so much for joining me on this explainer. And hey, here's to endless, efficient hot water in your future.